definition we just started. So yesterday we were here. We set the stage for definition. You can see before we introduce a definition, what did we have to do? Right? We have to clarify what is A, and we have to specify what is what? What is reference angle, right? Angle, how angles are measured, right? Every angle measured in a certain way, but they all measured from the standard position. They all measured from the standard position, okay? And then we talk about reference angle. So after angle measurement, after reference angle, and then we set the stage. So on that stage, we have already assumed the angle measurement. We have talked about the reference angle, and then we introduce these symbols. We introduce all these symbols, right? Every symbol specified, every symbol specified. Okay, so let's look at the definition of sine, okay? In these definitions, all of these definitions, okay, all these new rules, what is the input? What is the input for all these new rules? A, which is our angles that measure from standard position. Do you guys see that? Different textbooks uses different symbols. Some book uses X, X. Some book uses theta. Some books use alpha. They use different kind of things. But we need to understand the input for all 6 functions. Okay, for all 6 functions, the input are angles. Angles measured from standard position. Okay, so let's look at the definition, the sine definition, right? From input is A, and we have a rule for sine. What is the rule for sine? The rule for sine says the ratio. Okay, so let's put the points in place. Okay, so let's put the points in place in the rectangular system. Okay, so we're gonna put a point in place. X comma Y. So I'm gonna just pick a place. Right, there's an X, there's a point there. There's a point there, okay? And the line, so this is a terminal, right? This is a terminal. So we're gonna put a terminal in place. Okay, of course I can make it longer. You can see this line can be longer. Okay, so let's make it longer anyway. Okay, so and the point X comma Y is just any point. It's any point. Yesterday we explained the significance of this, right? So red dot. The red dot. Can you guys see the X comma Y well? Do you guys see that point well? X comma Y. It's important to understand that this point is arbitrarily chosen. It's arbitrarily chosen on the terminal. So the point can be anywhere. Of course, we cannot choose 0, 0. We cannot choose origin, right? Because it says other than the origin. And the output of sine of the angle measured, this is in standard position. Okay, It could be this one too, right? It could be this one too. It could be measured clockwise, counterclockwise, many, many different ways. You get many, many different angles, but it has the same terminal. And that terminal is going to be the one we consider on the terminal side of A, other than the origin. So that's X comma Y. So we must understand this, okay? And soon we're going to talk about Y unit circle, okay? So stay up, okay? So that's a definition. So if you see people ask you, give me the definition of sine, cosine in trigonometry, what do you say? You say, oh, it's opposite over hypotenuse. Is that definition accurate? Is that definition accurate? Yeah? Is that definition accurate?
We have to set the stage first, then everything.
That's right. You have to set your stage and tell the story. You have to tell the people if you want to be precise. Okay, you have this stage set. Okay, so the output is a ratio. Okay, then what about cosine? Then what is about cosine? Input is still angle, and the output is a ratio, but this time is a different ratio. It's X over R. And how about tangent? For tangent is also a ratio. You see the output is a ratio. It's Y over X, right? And what else? And a cotangent, right? And the output is a ratio. The emphasis here, I emphasize the nature of the input and the nature of output. Okay, so it's just been a variety of ratios. Okay, so cotangent is X over Y, and then it comes to cosecant, and this is a ratio again, right? It's R over Y, and the secant, it's a ratio, R over X, right? That's very, very important to understand. Okay, so when you look at this quantity, I put A here, right? What if I put X? It doesn't matter. It's just a placeholder. It's just a placeholder. Doesn't matter what name you call it. You can call it X, you can call it Y, you can call it baloney, you can call it hard, you can call it spade. Doesn't matter what you call. It is an angle measured from standard position. And the output are ratio. So here, these 6 functions basically give us ratios of different kinds, right? You have three quantities to work with: X, Y, and R, right? You make ratios in different ways. You just make ratios in different ways. And from this definition, a lot can be derived. I think many of you probably already know. And here, we want to revisit the definition of function. What is the definition of function? A function is a rule that assigns an element from domain exactly one element in the range. Yes, do you guys have that flashcard with you, or you can already recite it? By this time, you probably could recite the definition. Now, as we look at that definition and we look at these new definitions, these new rules, and these are functions. But these functions with new rules to describe them, you have to set a stage. You have to set a stage. Okay, so these functions are the more complicated one in the table basic one. Now, let's look at each individual. So the next question you guys have, the next question I'm going to ask, right, is why unit circle? Because why unit circle? Right? You can see in the definition, we did not say this point has to be on unit circle. Did we say that? Did the definition say you have to have this point on unit circle? Did it say that? Did it? Did it say that? No, absolutely not. Okay, so this dot I put here certainly is not on unit circle, right? On which circle, I don't know. You just have to find out, right? You just have to find out. If I draw a circle, right, like this, this is it's going to be an ugly circle if I draw it, but the radius is not going to be 1. But why you study unit circle instead? Could anybody contribute a comment on this side? How is this definition lead to? How is this definition lead to a unit circle? Yeah. How is this definition lead to unit circle? Anybody could answer that question? All right. Okay, so I'm going to draw a couple of circles, right? I'm going to draw a couple of circles and we're going to reflect on the definition. Because from this definition, we're going to figure out domain range. Remember domain range, intercepts, and all of those stuff, which you're going to need in calculus class. Okay? We're going to figure out so you don't have to memorize it. Okay? So first, why unit circle? Why unit circle? Suppose I have a circle of radius 2, right? And then I have another unit circle of, say, 4, right? Right, I have these different circles. Suppose I pick the 2 points on the units on these circles. Okay, so let's look at these dots, right? Suppose I have a dot here. There's a dot here. So suppose this is my, this is my XY. And suppose I have another dot. I'm going to put it here. According to this definition, suppose I'm working on sine, right? Sine is a ratio of y over r, okay? What is y over r? We drew the line of y, right? This is y, right? And this is another y. Yes? Y over r. These 2 triangles are what? Okay, let's look at these 2 triangles. there are of course, there's 3 triangles here, but we look at two of the triangles, right? This triangle, which is radius is 2, and the other triangle radius is 4. These 2 triangles, I mean this triangle over here, right here, the hypotenuse is 2, and this other triangle, the hypotenuse is 4. These 2 triangles are, what do we call them? They're similar triangles, aren't they? Right? They're the similar triangles. If they're similar triangles, the ratio of one side to the other, they're going to be the same no matter what you do, right? No matter what is the radius. Okay? For that reason, we decide, hey, we're going to use a unit circle. The unit circle is much simpler. Do you guys follow me? That's why we choose unit circle, because this triangle and this large triangle, they're similar. So the ratio of these 2 triangles, right? Y to R, right? So let me show you. You guys understand what I'm talking about? Okay, so I'm going to just put some numbers here. Okay. No answer. Nobody said anything. Okay. Okay. Suppose I call this guy Y1 and this is Y2. Okay. And the radius for the large triangle is 4, right? Is 4. And the radius for the small triangle is 2, right? And it's obvious that these 2 triangles are similar. Therefore, I will declare, okay, because of similar triangles, okay, this is geometry, right? Similar triangle, they're both right triangles, right? And they're similar. Okay, because these 2 lines, they're vertical, right? They're parallel. So in every sense, it's similar triangles. Therefore, the ratio of Y over Y1 over 4 is going to be equal to the ratio of Y2 over 2. And you can keep going. You can keep this process going. The ratio is going to be the same. Okay. So next time you draw a unit circle, you're going to have a Y3. Okay. So let me draw that unit circle for you. Okay. Unit circle. Okay, I'm going to make the unit circle a green color. Okay, so that's my green. Oh, well, it doesn't really matter. Okay, so this unit circle is going to be what? Suppose the Y is going to be, I'm going to call it Y. I'm just going to call it Y. How about that? Right, so this is the Y. You guys see that? Y. So by this token, right, because of similar triangles, I can just keep going. This is equals to what? That Y over 1. That's a ratio. So it doesn't matter which triangle, doesn't matter which point you choose, right? If you have a circle at this point, that circle, you will lead you another triangle. That triangle is going to be similar to all of the triangles we have mentioned before. So the ratio will stay the same. And that's why we choose unit circle. Do you guys follow that? You guys get that?
Yes.
So the same is for cosine, tangent, cotangent, cosecant, secant. So that's for the same reason, because of similar triangles. the ratio will stay the same no matter what is the radius. Okay, what is R? You guys get it? All right, so this, if you have taken trigonometry, you have learned this. I just want to review this so everybody will see it. With that said and done, let's see what happens if we choose unit circle. Okay, let's see what happens if we choose unit circle. Okay, because of this property, okay, so why unit circle? With unit circle, we still have the same stage set. Okay, so I'm going to copy and paste. I'm going to put this on the very top. On the very top. And this time we're going to choose unit circle because we know the ratio is going to stay the same. So now we're going to choose for R equals to 1. Because all the ratios are going to stay the same, right? All the ratios are going to stay the same. And what I'm going to do with this picture, I will forget about all these other, circles, right? I'm going to forget about all these circles, right? I'm going to just delete. I'm only going to save the unit circle, right? I'm only going to save the unit circle. Let's see if that will delete them all. Okay. Now, because I only work with unit circle, and this unit circle is too small, so I'm going to change the scale. So I'm going to make the unit circle blow up. I'm going to blow up the unit circle. Okay. So I'm going to blow up the unit circle. Because I know it's not going to make any difference for the output. I'm going to blow it up. So that's unit circle. Because the ratio, it doesn't make any difference on the ratio, what will happen? Suppose I pick a point, right? Suppose I pick a point on the unit circle, it should give me the same ratio. But it also brings incredible simplicity. It also brings incredible simplicity. What are the simplicities? If the radius is equal to 1, right? That means, whoops, the heart is off the place, okay? Sorry. About to shut the door, okay. Now, with the radius equals to 1, right? If radius equals to 1, what happens? All the formula will be simplified. So this becomes 1, this becomes 1, this becomes 1, and this becomes 1. You guys see that? Yeah? Simplified. Simplified. And now let's look at these quantities. Let us look at these quantities. Okay. Now, if we look at from the definition, okay, from the definition is the king. Now this point is x comma y. This point is x comma y. Okay. You guys follow me? So the stage set is still similar, but a little bit simplified. It's a little bit simplified. I want you guys to draw a unit circle now. Okay, how come I lost that? Let's see. I'm gonna have 1. Please show me. Huh, wrong place. It's a little bit off. Okay, so wait a second. I just want to just put the point in the right place. Okay, so now this is XY. Okay, so choosing unit circle does not change the output, maintain the output, simplify the operation. Simplify the operation. But with that said and done, let's look at these ratios, okay? Input are the angles, output are the ratios. So this is y, and this is x, right? And y over x, x over y, 1 over y, 1 over x. So this is y, and this is x. Everything else stay the same. Everything else stay the same. Now, let's look at all the possibilities, right? So what does this tell us? What does this tell us? After we've done the simplification, right? Let's see what this tell us. Now, input is the angle, output is the ratio. Output is a ratio, right? And the ratio is going to be y over 1. Y over 1. Right? So this is y. What is y? Y is the output. Y is the output for sine. Okay, so let's look at this particular function sine. Okay, so what I'm going to do is that I'm going to clean this up. I want you guys to have a separate line. Okay, I'm going to take this circle with me. We're going to study domain and range. We're going to study domain and range. Just from definition, Okay, so all I'm going to take the sine. Because on this stage set, right? This is sine, and what is y? So this is a y value. That's y. What is the value of y can be? What values y can be? If the point is on the first quadrant, right? Depending on where is your terminal. If your terminal is here, well, if your terminal overlap with the red line, right? If this is your terminal, what would be the y? And your point will be here, right? Your point will be here, right? What's the y value for this point? 0, right? Very good. Now, if I choose another point, okay, another terminal, I measure another line, I measure another angle from standard position. And for this point, what is y? Y is the sine output. This is the output for sine. And that's the output for sine. If I keep drawing these, right, another terminal, right, which is the terminal of many lines, many angles, and what will be the y value? The y value is this much. 0, more than 0, more than 0, more than 0. What if the terminal is here? What if the terminal overlap with the y-axis here? What will be the y value? Suppose my point is here. What is the y value? Tell me, what's the y value?
1.
1, that's right. So all of these y values, look at them. All these y values is between what? Between 0 and 1, right? 1 be the highest, right? 1 be the highest, right? You follow me? If I keep going, okay? And the terminal is here. What is the output? The output will be what? Will be this much. Positive. Well, you know, all these lines are positive, 0, right? This line as the output of sine is going to be less than 1. So as we draw the terminal, as we measure different angles, and the next one, the output is what? This is y, right? And until I draw this terminal, what will be the y for that point? 0, right? Is that 0? Right? If I keep going, right? So all of these y's are positive. And this tells us that the sine output are positive when the terminals are in first quadrant and second quadrant. Right? Yes? Did that refresh? Okay. So if we keep going, right? The terminals are here. This is the terminal. And what will be the y? The y is the output for sine. This time it's below x-axis, and this time y is negative. So sine value can be negative in the third quadrant. But how high is this? Well, compared to -1, it's more than -1. You see, this is -1. This is more than -1. If I draw another terminal, and what will be the y? And this will be the y, right? This will be the y. And this y is also more than -1, right? But all of these are negative because the y are negative. They're below x-axis, right? So all of these, let me mark it here. All of these y's are positive. All of these y's are positive, and all of these are negative, right? If we keep going, if my terminal ends up here, and I pick the point on the unit circle, what is the y? The y is exactly -1. And I keep going, it's negative. So I keep consider all these possible terminals. Consider all these possible terminals. And I'm thinking of y because y is the output for our what? Y is the output for what? For sine. And all of these are negative. So sine are positive on the first two quadrants, negative on the third and fourth quadrant. And the sine output, the sine value will never be less than -1, and it will never be more than +1. Do you guys agree with me? Yes? No matter what angle is, right? Because yesterday we talked about all possible angles. So we have to consider all possible angles. All those angles, they correspond to these reference angles, right? And with these reference angles, we have defined the ratio. And in the end, we know that, oh, it's just the y on unit circle. So in the end, what can we say about the domain and the range? What we have described is the range. Domain are the choices of angles. Is there any angle that cannot be used as a domain? Cannot be used for input? None, right? Every angle can be used as, as input, right? Because every angle we can find the y, right? So the domain is from -infinity to +infinity. The range is sine of any angle is between -1 and +1. Okay, the one-word sentence. So I'm going to give you another form. I'm going to give you these two forms. These two forms you are going to need in calculus, okay? Or the absolute value of sine of any angle is going to be less than or equals to +1. If you guys, some of you remember this from your previous learning experience? Okay, -1, +1. That's helpful, that's good. But if you don't know this one, knowing this guy is not extremely helpful. Okay, when I was teaching Math 190, when I use this form, you know, for squeeze theorem or something, a lot of students were totally lost. They were bewildered by this expression. Inequality, which you need definitively when you're taking calculus class. All three, this three sentence, right? This tells us the output is between -1 and 1, which we just demonstrated. And this one is saying the same thing. The absolute value, if you take absolute value of all these y values, is going to be less than or equals to 1, because if you take absolute value of everything, it's going to be less than or equals to 1, right? Or this one, all of these are correct forms for range. But which one is most useful? The first one. The first one is most useful. The last one is least useful. It's correct, but doesn't get you more points. It doesn't get you more points. So one sentence, domain range, very important. Okay, you will probably see these sentences in your calculus textbook. Okay, one sentence will be saying, for any angle A. Okay, so let me clean this up. Did I clean this up? This is one sentence, okay? And the other one, I want you to write them down because you will be quizzed on these often, probably more than once. Domain range. Any questions? Any questions?
Professor, I came up with a very good example for domain from -infinity to infinity. Just have a more feeling about that domain. Can we choose an angle 36,360,360 degrees? For example, what is sine of or cosine of that without using calculator?
Right. Sure. Okay, you just have to go around and round and round, right? Many times.
Absolutely. What you are showing us, the visualization, understanding by definition and domain range, we can go even faster than calculator, get the answer, so on and so forth.
That's right. Okay. And the other thing is, I want to deepen your understanding of this process. Some of you might have brought that unit circle with all the numbers being marked on for the special value. Has any one of you have that? I have that. I have one ready for you. Okay, but I just want to tell you what to look and where to look. Okay, we often have students have that thing over there when you ask them what's the domain and range and they're lost. So that's the issue. It's you have a picture, you may or may not know how to read the picture. That's what I'm saying. So I'm trying to help you to figure out, right? So suppose you have that beautiful unit circle, right? Suppose you have that unit circle. Actually, I found these, I have these unit circles and I'm going to share with you. Okay, so that unit circle. Okay, I'm going to find it. I'm going to send it to everyone, all right? In case that's the unit circle you're familiar with. Okay, I have it too. Actually, I found this online. right here. Oh, wait. It's not what I wanted. That has too much. I just want to have unit circle alone. Unit circle alone. You know what? We just unit circle. Those are the other files I have created for you. There, I found it. Okay. This unit circle. Does it look familiar? Is this pretty close to what you have, you used to know? You might have, if you have taken a class recently, some of you might know this, right? Some of you might know this with special angles and all of that stuff. Okay, so I'm going to show you how from this chart you can tell the domain and range for the function you want, for the function in consideration. For example, okay, we have this, you know, this line we call the standard position, right? Now we still talk about, you know, this is unit circle, right? And if the terminal is here, y is 0. You look at the blue number, right? You look at the blue number. Because sine is defined as y, right? And so all these points are on the unit circle and they're marked with x, y. And look at these values, right? This is 0. This is half. This is 1/√2. And there are a lot of y's in between, right? There are lots of y's in between. Do you guys follow me? So all of these are y. This is y equals 0. This is y equals to half. This y equals to 1/√2. And this y equals to √3/2. And this y equals to 1. That's what it meant. And that's why it tells you so much information out here. In particular, now this is y equals 0. And for these, y is negative, right? Negative half. The y is negative √2, negative 1/√2. And this is a negative √3/2. Do you guys understand what I'm trying to show? Is this unnecessary or this is helpful? Because I don't want to be too slow. Too slow for you. Am I too slow for you? Now, you look at these y's. Okay, you look at these y's. All of these heights are y's in the first quadrant, and these represent the output for sine. You guys follow me? We talk about you have a function, you have an input, you have an output. Okay, so what are these output? You look at these output visually, right? Each one is, this is the highest positive number, and this is the lowest negative number. Everything's in between, right? And you certainly have heights over here. They're just not being marked. So you can imagine all of these bars, these are the output. These are the output for sine of different angles. How many angles out there? Infinite, as many as you wish. Some of them are special, some of them are not. But all of them included these output in the first quadrant positive, in the second quadrant positive, third quadrant negative, fourth quadrant negative. You can tell from the place, and because these are above x-axis, of course they're positive. These are below x-axis, they are negative. So they're the smallest one being -1, the largest one being +1, and there's everything in between. All these heights are the output. Therefore, naturally, what do we say? What do we say? -1 is less than equals to sine of A, and sine of A is less than equals to +2. This is the critical inequality you please Please make sure you understand it, and then you can use it, and it will get you points in Calc. How many points? Probably about 10-ish, depends on how teacher tested. 10, 20, depends on how many times you're going to be tested, right? 10, 20 points. Are you guys with me? So you have the visual, we have the definition. You got it? So what you do, actually, you look at the blue numbers, don't you? Yes? All those blue numbers are examples of the output for sine. And all of these blue numbers, they're between what? Between -1 and +1. And there are many numbers in between them. And that's what this is saying. The output of sine is between -1 to +1. Have I made myself clear?
Yes.
Any questions? Very useful inequality. You have the visual, we have the definition, and this comes directly out of definition. Okay? All right, clean up. This form, once again, when I was teaching calculus 1, I asked students to give me the range for sine. They will give me this. But when I write down this, they're lost. They're helpless. Some of them are helplessly lost. What does that mean? It means the same thing, just a different form. Okay, so now let's look at cosine. Let's look at cosine. Are you ready? If we look at cosine from the same place, right? And we know we're going to use a unit circle, and we reflect on definition, right? Where's our definition? Our definition is here, right? It's about x, right? It's about x, right? The input is A, any angle. Well, could it be any angle? The output is x. What are x? What are x? What are x, everybody?
Are they the red numbers?
That's right, you got it. The red numbers. And what is the visual? The red number represent
The inputs?
The x, right? I wouldn't say the input for cosine because that could be confusing. Okay? The horizontal measurement from the origin. Okay?
So, Professor, still input is the angle.
Input is angle, right? Because we don't want to have too many input. It could be confusing. Right? So all of these red numbers, these red lines are what? Are the output. Are the output for what? For cosine. For cosine. Okay? So if you look at these, values, right? Look at these values. These are how long they are, right? These are how long they are. Yes? And there are lots of red bars in between, aren't they? Aren't they? Yes? And what is the longest one? What is the shortest one? There are many in between, right? On this side, the red is what? These are what?
Positive.
They're positive. And how about these? They're negative, right? And these are negative, right? And these are positive. So what does this tell you? it tells you the red bars are between -1 and +1. In the first quadrant is positive, fourth quadrant is positive, third and second are negative. Isn't that so obvious? Isn't that so obvious to you now? Yeah? So what is the range for cosine? The range for cosine is about the biggest value cosine output can be and the smallest value cosine can be and everything in between. What is that numerical expression? What is the range for cosine?
-1 is less than or equal to cosine A, which is less than or equal to 1.
Same, right? Very good. Is there any angle? Very good job. Very good job. Less than or equals to cosine A, which is, it can be any angle. Along the way, we have every angle is okay. Every angle can serve as input, and the output is the red bars we just draw, and they are between -1 and +1. And this is the form that's going to be most useful to you. Most useful to you in the sense that you are going to get points for using them. Is that clear, everybody? Okay. So now, the range for cosine. Okay, so so right here, so I'm gonna put domain and range in a separate line. Domain and the range for what? Cosine A. Okay, so the domain is what? All real numbers. All real numbers, it means it can be any angle, right? Because we know that all those terminals we drew, those are just terminals. And one terminal can correspond to many angles, right? And now the range. The range, like we said, there are 3 forms. I'm going to give you all 3 forms. They all will be tested, though. They will all be quizzed or tested. You need to know all 3 forms, but you also need to know what is most important to you. Okay. The next one is the absolute value form. Some professors like to use this form. Okay, especially those nerdy professors in 4-year schools. You never know, you know? Right, Farouz?
Yes, Professor.
I've been there. Okay, you understand all three forms mean the same thing. Okay, all 3 forms mean the same thing. One sentence, you know, you might find myself kind of obsessed with this one sentence description of domain range, right? One sentence domain range. Anybody has any questions? Any A means angle. It could be degree, it could be radians. Okay, we haven't get started to train you to use radians. Or the other form, right? For any angle. And the other form, this is really rarely used.
Discussion question, Professor.
We got a question? Okay, how do we get domain? How do we get domain? Okay, how do we get domain? All right, We know domains are angles, right? For sine or cosine, right? So what you do is that you measure angles from these standard positions. From the standard position, you just measure angles, right? Could this angle be an angle? Could this angle be an input? Very good question. So let me just first clean this up, right? This is the question you ask, right? You will choose, you measure an angle from the standard position. Then you ask the question, from the definition of function, if this angle is used as input, does it have a unique output? The answer is yes. This is the output. You follow me? I should use the blue. You follow me? The output is a blue bar for sine. Yes? And you keep doing, you say, oh, this angle works. How about the next angle? Next angle, next angle. You measure from 0 to infinity. Every angle, every line you draw arbitrarily can be the terminal of an angle. And therefore, your angle can be any real number. Does that make sense?
Okay. Yeah, thank you.
Right? So that's how you analyze. So because we know the input is angle, right? So when you draw this angle, this is the terminal, right? And that angle is measured from standard position, right? And of course, there are many other angles that has something to do with this reference angle. And is that output unique? Yes, the output is visible. It exists. It has exactly one output. You see, I'm quoting definition of function, didn't I? So for each input angle, there's a unique output, the vertical y value. Do you guys see that? Therefore, the domain is all real numbers. All real number means all real angles. Why real angles? Could be decimal, definite fraction, radians. It could be angle measured clockwise, counterclockwise. Every possible way, as long as you measure starting from the same place, all the possible angles you can think of, every one of them will be fine because every one of them you will be able to find the y value. Yes? Yeah? So that's
Thank you.
Sine and a cosine. Very good question. Did everybody else get it? Right, remember we spent so much time on the angles, right? Angles, reference angles. For what? Is preparing for this moment. This moment. Domain range discovered. Do you have to specifically memorize anything else? You just have to know where to look, right? There's a lot of materials online. You just have to know where to look. If you master ARD, you will know what to look, where to look. That's what we're trying to show you, okay? In this class, I don't use much of technology, but I'm not against using technology. But when you use that technology, you have to know what to look for. What is the interpretation? What is the interpretation? Okay, so then we're going to continue to study domain and range. So what's next? We've done sine, we've done cosine. We're going to do tangent, right? Shall we do tangent?
Good idea.
All right, let's do tangent. You guys ready? Let's look at tangent. So I'm going to borrow this, unit circle one more time. How is tangent defined? How is tangent defined? We have that stage set, right? We have that stage set. How is tangent defined on that stage? Huh? How is tangent defined? How is tangent defined? Y over X. Why the blue, red? Are you guys with me? Yeah? Y the blue, X the red. So we do Y divided by X. What will happen? The blue divided by red, right? For example, those are special angles, but there are many, many angles in between, which terminates at these terminals, right? Do we understand that, right? So this is represent different angles, right? You choose a point on it because it doesn't matter which point you choose, so we choose the points on the unit circle. You guys with me? Because on that stage, we just talk about it doesn't matter where you choose. If you choose all the points on the unit circle, you're gonna get the same ratio. That's why we choose the points on unit circle, right? Because it makes things easier because the denominator will be 1 in the case of sine, in the case of cosine. Okay, so for that reason, now to determine tangent, what do you have to do? We know we're gonna take the blue number, right? Because y is what? Y is sine of A. X is a cosine of A, right? Is that right? Do you guys follow me? Right? Now, and sine of A is Y, cosine A is X. On these, all the cases, and no special cases, non-special cases. Why do I mean by non-special cases? It could be something like this, right? That's non-special cases. In between, there are lots of those cases. So there will be other blue and red, right? There are lots of blue and red. You guys follow me? Now, when we look at the value, we have to look at input and output. So we're gonna do some blue divided by red, right? Because the blue is sine of A, the red is a cosine of A. Take the first point, for example. Let's start from the easiest, right? Let's start from the easiest. Let's start from the easiest. Are you guys ready? I'm gonna give you a little table. Let's see if this table works this way. No. I'm gonna do this. I'm gonna do a little table for you, okay? There. This table. When A is 0, what is the terminal when A is 0? The terminal is here, right? Right? That's A is 0. Many angles, 0, 2 pi, 4 pi, 360, 720, and so on and so forth. And the blue number is 0, the red number is 1. So what is tangent? So tangent of 0 equals to what? The angle is 0 is equals to what? Is 0 divided by 1, right? 0 divided by 1 is 0. So tangent for input A equals 0. For input 0, the output is 0 too. Okay, so let's look at this other angle. Let's look at this other angle. This angle, right? This angle is 30 degrees, or pi over 6. Okay, pi over 6. So for A equals to pi over 6, some of you may not be used to these radians, but we're going to cover another time. Okay, just for now, just take it. Okay, so tangent of pi over 6 is what? It's going to be the red number divided by the blue number divided by the red number, right? Yes?
Yes.
What'd you get?
I can answer, but leave it.
I know. What'd you get? So how about we do a breakout session, breakout rooms, right? We might have some gaps in between, you know, as we go through the lectures, and just hold, you know, get your question. Maybe we should do a breakout room. Peruse. We're gonna do these 3 points. We're gonna do blue divided by red.
Good idea, Professor.
Okay. Okay, I got some decimal numbers, but I want to tell you, for these special points, you must give your professor the perfect, precise number. Not only I like them, your professors at four-year school will love them. They don't like to see decimal numbers. They just like to see like √2 over, you know, √3 over 3. They like to see those numbers. They see those numbers, they're happy. They don't see those numbers, they're confused. So do whatever you can get point for, okay? So I'm gonna give you an example before we finish, before I break out the room. So the numerator is gonna be 1/2, that's the blue. The denominator is gonna be what? √3 over 2, right? And you're gonna simplify this. The numerator is, the denominator is 2, therefore the answer here is just going to be 1 over √3. Okay, you don't need to rationalize it for now. So what I want you guys to do, okay, I want you guys to go to the breakout rooms, if you wish. You do it for these 4 points, 1, 2, 3, 4. Could you do that for me? If you have more time, you can just keep going. You can just keep going. I'm gonna give you like 5, I'll give you until 12:30. How about that? You're gonna do some algebra, okay? You're gonna do some algebra. Ready?
Yes.
Breakout rooms. You choose your room, open all rooms. If you stay with me, great. If you wanna go to Farou's room, no problem. Farou's is ready for you. I'm gonna send you this. Unit circle, because sometimes I think the number might be a little bit difficult to see. Is that right? Huh. Let's see that figure. That figure doesn't go. Let's see. You can just Google online, type unit circle. That unit circle is going to pop up. Okay, it might look clearer that way. You guys with me? Because I took that from online. Let's see if I can send this. You guys know what to do, right? So for A equals 0, you're gonna do, the input is 0, you'll have a unique output. The input is pi over 6, we have a unique output. Okay, so A 0 can be in the domain, A equals pi over 6 can be in the domain. So we keep going. The next one is A is pi over 4. That's 45 degrees. Okay. If you're not familiar with this, we will do another session to one of those days. We're gonna, do the transformation. But now I'm just assuming you guys know this, right? So that's blue divided by red, right? In this case, the numerator is the same as the denominator. So it's equals to 1. And so for pi over 4 and everything in between. So for 0 can be the input because for each input there's unique output. So 0 can be input, pi over 6 can be input, 30 degree can be input, and everything in between are okay. Everything in between are okay. Do you guys follow me? And the last one I recommended is that pi over 3. That's a 60 degree. Okay, so in that case, tangent of pi over 3 is going to be that the blue divided by red, okay, the blue divided by red, root 3 over 2, the red is half. And equals to root 3. So the angle can be everything from 0 all the way up here and getting closer. So I'm going to close that room. You guys with me? So I want you guys to think about, as I'm closing the room, those people are coming back. And what happens when the angle is pi over 2? The angle is pi over 2, or in the neighborhood of pi over 2. What will happen? What happens? What happens? Thank you, Farouz.
You're welcome, Professor.
Is everybody? Very nice contribution. Okay, people are contributing, even though I was just telling you that your professor may not like those decimal numbers, right? But if you get the right answer, of course, but sometimes we want a precise answer. Those mathematicians, they're nuts. They're nuts. Okay, they're just as nutty as I. Okay, all right. So we keep going, right? You can see the angle can be 0, can be pi over 6, and can be all of these angles. And all these terminals, of course, you can add, to 360 degrees or 2 pi. You're going to get lots of other angles because those terminals will be fine. But when you hit pi over 2, what happens? If you take the blue divide by red, what do we get? What do we get? Can you do 1 divided by 0? And we do 10 pi over 6, pi over 2, sorry. What happens? We encounter 1 divided by 0, right? What do we say about that? 0 can, I'm sorry?
Oh, I was about to say, isn't it undefined?
Exactly. We can never use 0 as a denominator. And because it is undefined, what happens? For this input, there's no meaningful output. Okay, I'm citing the definition of function again. I'm citing the definition of function again. For this input, no meaningful output. What do you say about that input? Huh? What do you say about that input? What do you say about that input? Cannot be in the domain. Okay, so pi over 2 cannot be in the domain. Then you say, how about we add 360 degree to 90 degree? Would that still be in the domain? No. All the angles that terminates on this cannot be in the domain. So imagine we talk about that. How many angles could there be where terminal on this line? Infinite, right? So pi over 2 cannot be. Right? Pi over 2 cannot be in the domain. Where else do we see divide by 0? Where else we see divide by 0? There's another terminal, right? Right? Okay.
Professor, of course, we are talking about the domain of tangent.
Right, I'm talking about domain of tangent, yes.
Thank you.
Yes, we're talking about domain of tangent. You see, we're taking the input and we work on the input and we do the blue number divided by red number. Why we do blue divided by red? Because that's a definition of tangent. Right? We realize we can do all of that in blue divided by red, okay, except we encounter 0 as a denominator on this line. And 2 terminals are involved. 2 terminals are involved. Right? One is from here. And this other one, we have 0 as denominator. 0 as denominator. So what are these 2 angles? That the input cannot be. Input cannot be pi over 2. Input cannot be 3 pi over 2. Or you can say the input cannot be negative pi over 2 because negative pi over 2 ends at the same place. And any angle that ends up with these terminals, all of those angles cannot be in the domain of tangent. So when we study sine and cosine, any angle can be in their domain, right? Because for each input, there's a unique output. For tangent, however, we have to exclude angles that terminate on these 2 lines. And how do we describe that? Right? So you can keep going, keep dividing the blue by red, right? Until you hit these 2 terminals. So let's look at what are the numbers that cannot be in the domain. Okay, angles that cannot be in the domain of 10. Okay, cannot be. Cannot be. It cannot be pi over 2, right?
Or 3 pi over 2.
It cannot be 3 pi over 2. And what else?
We see a pattern, Professor.
We see a pattern. If you're sitting on pi over 2, right? There are many, we know that we just talked about, if you have a terminal, there are many angles we can use this terminal, right? So if you think pi over 2 is 1, this is pi over 2. If you go around, you get another one, right? And if you keep going around and around, there are many. So you go one around, what you get?
5 pi over 2.
That would be 5 pi over 2, isn't it? Do you guys follow me? You basically take pi over 2 plus 2 pi, right? You guys follow me? Pi over 2 plus 2 pi. Can you guys operate pi over 2 plus 2 pi? Can you guys do that? What do? You find common denominator. The common denominator is 2, right? Plus 4 pi divided by 2. And that's going to be what? That's going to be 5 pi over 2. Is that right? Does everybody follow me? So we cannot be pi over 2. We cannot be 3 pi over 2. We cannot be 5 pi over 2. Anybody has any question? Will the list go on? So what else cannot be? Suppose my terminal is here. We know that this terminal and all the angles related to it cannot be in the domain, right? And what is this angle? This angle is a measure from the standard position, and this is a 3 pi over 2, right? If I go around, what do I get? I think I need to, I probably have confused you. Okay, so what is the angle? What is this angle? Right, this is a terminal. I'm measuring the angle. Here, what is this angle? It's 3 pi over 2 plus 2 pi, right? Yes? You guys follow me? 3 pi over 2 plus 2 pi. Are you guys doing the algebra?
7 pi over 2.
Wonderful. 7 pi over 2. 7 pi over 2. Is everybody with us? Right? So it cannot be pi over 2, cannot be 3 pi over 2, cannot be 5 pi over 2, cannot be 7 pi over 2. The list go on. So what will be the next number it cannot be? Do we see a pattern here? Okay, so let me clean this up a little bit. So maybe you see a pattern. Okay. Cannot be 5 pi over 2. It cannot be 7 pi over 2. What will be the next one? They are odd number. We didn't finish that sentence. They are odd numbers. Odd numbers about what?
Odd numbers of pi over 2.
They're odd number multiples of pi over 2. You see it. Very good. Very good job. Okay. The first one is 1 times pi over 2, right? 1 times pi over 2. The second one is what? 3 times pi over 2, right? The next one is 5 times pi over 2. So you got it. Odd number multiples of pi over 2. You're right, Kelly. 9 pi over 2. And the next one is 7 times pi over 2. And this list just go on. So can we express a general form for it? Because if you keep listing it, can we have a general form to represent it? So first, we're going to express it in words. Okay? Cannot be, right? In the domain of tangent, it's an odd number multiples of pi over 2. Could that be negative number 2? Could it be plus minus 2? Huh? You guys? Think about clockwise measurement, right? So the multiples can be positive, negative integers, right? Yes? So how do we express the odd number multiples of pi over 2? And here it is. 2k plus 1. Of course, this is not the only form, pi over 2. Where k is integer. How do we verify we got the odd number multiples of pi over 2? Okay, we have 8 minutes.
So, Professor, we can.
Shall we do a breakout session?
Professor, before that, now I guess you were trying to tell us the range of tangent. Now we can write it all real numbers except multiples of odd multiples of pi over 2.
Right, we cannot, we're not doing the range today. We cannot do the range today. Time is running out. I want to get you guys to understand the domain. These are the input that cannot be.
Yes, domains.
I'm going to talk about range tomorrow. Okay, but I want you guys to understand this representation. Okay, how do we understand this representation? Just to give you some examples, okay? Because you want to represent all of these and more, right? So this form has to be representative of any angle from the list. You name it. It could be 11 pi over 2. It could be 19 pi over 2, right? All of these numbers you have to be able to represent. So now I will just give you a couple numbers for you to verify this is the right form. So I'm going to give you 0. And you're going to verify that this is going to give you one of those angles that cannot be. Okay? And the next one is k equals to 1. K equals to -1. And so on and so forth. K equals to 2. Do you guys follow me? Let's just do it in class. Don't do the breakout room. We can do it tomorrow if we need to, okay? So what you see is that if you use this form, these are the input that cannot be. When you have 0, 2 times 0, right? So that's going to give you pi over 2, right? That's going to give you pi over 2. Is pi over 2 on the list of input that it cannot be? Yes, it's right here. For k equals to 1, so 2 times 1. So that's going to give you what? What is it going to give you? It's going to give you 3 pi over 2. Is 3 pi over 2 on the list? Okay. And the next one, if k is -1, what happens? So that's going to give you 2 times -1 is -1. -2 plus 1 is going to be negative pi over 2. Negative pi over 2 cannot be in the domain as well, right? Because it's just measure, it end up the terminal with 3 pi over 2, right? Do you guys follow me? Right? This is the angle we call negative pi over 2. It has the same terminal with 3 pi over 2, which is a measure this way. You guys follow me? Right? So negative pi over 2 cannot be in the domain either, just like all those many other things. So what you're doing, you're verifying all of these is, this is indeed a good form. This is a good form. This is not the only form. So this is a 2. So you have, in this case, you get 5 pi over 4. Does everybody follow me? I know we're near the end of the class. You might be tired. Okay. And if you have a -2, okay, and you will have that -3 pi over 2a, which is cannot be in the domain. So the list will go on, and this, as you choose a different value for k, all the values that cannot be in the domain will be represented. That's the point. Does everybody follow me?
Yes.
Good. Any questions? I want to make sure you understand this. This is just a domain, okay? So in conclusion, domain for tangent A, okay? This is how we express it, okay? A cannot be, so we have to use exclusion because there are too many that can be, okay? So the way we represent it is we say A cannot be all of these. We can only, in other words, A can be any angle except these. How many are there? Infinite.
For all values of A, for all values of A, angle A, right, Professor?
A cannot be. A cannot be.
Yes, A can be all real number except those.
Right, exactly. Could you type it? That's so cool how the equation holds up. I'm glad to hear that. You find it cool. Thank you for that comment, Vincent. Right? So when you do it this way, when you follow me doing this way, do you think you have to memorize these things? I hope not, right? I hope not. Over time, you realize, oh, it's obvious. I don't have to memorize this. I got it, and I can do it. I can do it on the spot when needed, right? Very nice, very nice. And tomorrow, we're going to continue on this endeavor, okay? And of course, we're going to talk about the graph, you know, but that comes later. But I just want to show you, just from the definition, we can discover so much information, so much information. You don't have to look elsewhere. That's why we say definition is the king. Well, whatever you think will be, you know, adequate to express that, or definition is the key, right? Or definition is the precedent, or so whatever you call it. So what will be the proper word for it? Definition is really, really important, right? You will find its importance even more when you're in calculus class. So what I'm doing here is merely to show you how to study a definition so that you're going to use these, you know, the ways hopefully will help you to give you some ideas as how to study those definitions in your calculus class in order to make it and ace it, right? You need to spend time on it. You need to think about it. Every word counts. Okay, there's not many redundant words, right, Verus?
Yes, Professor, and learn
every word counts. Yeah.
Learn the higher level math language, the codes, the way you are saying it by definitions.
Yeah.
For the last part, domain for tangent A cannot be 2k plus 1 then of pi over 2. You define the k is integer. You did not define the A. What is it? imagine if it was a function machine, we needed as a programmer, we need to define A. What is A for domain?
They're angles. They're just angles. A is angles measured from standard position. Okay. I'm sorry.
It could be any. It could be any values, right?
Right. It could be any value.
Very well.
And all of those values will be either treated as a degree or radians. If you don't have a degree attachment, it's going to be treated as a radians.
Yes.
Okay. So now I'm giving you another form of the domain expression because you can use 2k minus 1 as well. There are many forms to express odd number. Okay. Some textbook may prefer 2k plus 1. I think 2k plus 1 so far is the most popular, but don't quote me. But there's some weirdos, or some, I wouldn't say weirdo. That was very offensive. I don't mean offensive. It's just a personal preference. Okay, I take that word back. So please just pretend you never heard it. Is that 2k minus 1 will also give you an odd number, right? So over time, I want to expose you guys to these expressions because in the future, you're going to use them. You're going to use them in Calc 1, Calc 2, maybe Calc 3. Okay, so you need to get used to it. This course is called Pre-Cal, and we're trying everything we can to do it to get you ready for it. It's a big jump. It's a big change. It's going to be a big change. I knew it because I've been through it. Okay, it's not trivial. It's not trivial. Anyway, without further ado, we have come to the end of the class. I will see you guys tomorrow.
Thank you, Professor.
Thank you. Thank you for your help.
See you tomorrow. You're welcome.
I will see you guys tomorrow. Great job.
Thanks for the lecture, Professor.
Of course, my great pleasure.